Okay, for 1C, we're going to talk about sets and Venn diagrams. So mostly the relationships between sets, subsets, supersets, and then how to use Venn diagrams to analyze those relationships and kind of visualize them. So make sure you write down the title and that this is 1C. Few definitions you'll need to get down. A set is a collection of objects. The members of a set are all the individual objects within it. Few specific notations we use in math. To indicate a set, we'll use braces. They're kind of the curly brackets. And then sometimes sets have infinitely many members, and so you're not able to list out all of them distinctly. In that case, you're going to establish a pattern and then use an ellipsis to indicate a continuing pattern. A Venn diagram is a diagram that uses circles to represent sets. All right, so we'll use braces to write the contents of each of the following sets. The set of countries larger in land area than the United States, and the set of natural numbers greater than 5. All right, so for the first one, there are 2 countries larger in land area than the United States, and that would be Russia, Canada. So there are 2 individuals in that set. And then the set of natural numbers greater than 5 would be 6, 7, 8, and so on. The dots indicate that the list continues indefinitely. Okay, a Venn diagram. So a couple things to note first. Generally, when we make Venn diagrams, you'll want to include what we call a universe, which is the rectangle that surrounds it. So that's the universe of individuals that you might be discussing. It's not always the case that it's included. You'll see Venn diagrams used in many instances in like not super formal contexts, and they don't include a universe, but I wanted you to know what that is called. And so let's look at the relationship. It looks like we have 3 sets that we're discussing here. The set of whales, the set of mammals, and then everything outside the set of mammals, so non-mammals. And the relationships between these things, the set of whales is completely encompassed inside the set of mammals, so we say that whales is a subset of the set of mammals. You can also say that mammals is a superset of whales, meaning it completely encompasses whales. Sorry, I wrote into my picture there. All right. So here's another relationship you can have between sets. So here we have mammals and fish. There are no mammals that are fish. So we say fish are disjoint from the set of mammals. A synonym of disjoint is mutually exclusive. And it just means there's no overlap. There's no fish that are also mammals or mammals that are also fish. And then you can see that the universe outside of those consists of other animals. So like in here might be birds. They're neither mammals nor fish. And other things. Okay, so here we have an overlapping set. This is the set of doctors and the set of women. And it's, I suppose, set inside the universe of people. It may be people or maybe more specific professions, etc. All right, well, these are overlapping because there is an overlap between doctors and women. Some doctors are women. And so that space where they overlap represents Let me actually write it in a different way. Female doctors. Now, this is just a diagram, so don't get hung up on like how much or how little they overlap. That doesn't matter, and that's not supposed to be indicative of the actual amount of overlap in the two sets. If they overlap at all that's indicating is that the two sets do share some common individuals. Now, it is important if one is specifically a subset of the other that you completely contain it within the superset. So let's see, everybody who is a doctor went to school. So if I look at the subset of people who went to school, all doctors went to school. All right. So here are the three relationships we just discussed. Set A is a subset of B, then all members are A are also members of B. If A is disjoint to B, then they are mutually exclusive. They have no members in common. And if they are overlapping, then they share some of the same members. So here's an example. Describe the relationship between Democrats and Republicans and draw a Venn diagram showing this relationship. Interpret all the regions of the Venn diagram. So this isn't talking about values or anything. They can share values in common, but when you register to vote, you have to register either as Democrat or Republican or independent. There's no other options, so they are mutually exclusive or disjoint. And the universe would be that of independents and people of other political parties. Okay. So this one's a little review. If we draw the sets of natural numbers, whole numbers, integers, rational numbers, and real numbers, if you don't remember the relationships between these, I'll explain them, but here it is. So natural numbers are counting numbers starting at 1. Whole numbers, exact same set, except it includes 0. So it's 0 to infinity. Integers, including positive and negative numbers, so it would be more like -2, -1, 0, 1, 2. Rational numbers includes integers and fractions that are not integers. So this includes everything in integers, but also -1/2, -1/4, and so on. And there's no real way to actually indicate that. Rational numbers are dense, meaning we can't write them in a specific order because there's always infinitely many rational numbers between any two rational numbers. And then real numbers is everything else, including irrational numbers being numbers that can't be written as a fraction of integers because they are non-terminating, non-repeating decimals. So these are all supersets of one another. The only thing outside that would be what's left over, complex numbers, so your imaginaries, etc. All right, categorical propositions must have the structure of a complete sentence. One set appears in the subject, the other appears in the predicate. For example, in the proposition where all whales are mammals, the set whales is the subject set and the set mammals is the predicate set. We usually use the letter S to represent the subject set and P for the predicate set. So we can rewrite all whales are mammals as all S are P, where S is whales and P are mammals. And that just allows us to shorten the actual sentence and analyze more of its logical structure. Okay, so all S are P means all whales are mammals and is indicating a subset relationship between whales and mammals. No SRP means no fish are mammals, if S is fish and P are mammals. And that indicates no SRP indicates a disjoint relationship, mutually exclusive. Some SRP indicates an overlapping relationship. And so in this case, looking back to a previous example, S would be doctor or women or doctors, and P could be women. Some S are not P. So in this case, if S is teachers and P is men, that's indicating a certain space within the Venn diagram. We're looking at the set of teachers that are not men, aka the set of teachers that are women. All right, some dogs can swim, and we can rephrase that to some dogs are animals that can swim. And so if we want to construct a Venn diagram to represent that situation, so we can look at the set of dogs and the set of animals that can swim. Since it's some dogs can't swim, we have an overlapping situation. And we're going to put an X to indicate where in this Venn diagram our categorical proposition lies. And it's right here, the dogs that can swim in the overlap. Okay, so here we're given a study designed to learn whether pregnant mother's status as a smoker or non-smoker affects whether she delivers a low or normal birth weight baby. And the table shows 4 numbers which correspond to the 4 possible combinations of the baby's birth weight status and mother smoking status. So here we have the mother was a smoker and the baby was low birth weight. There were 18 of those. Here, the mother was a non-smoker and the baby was still low birth weight. There are 14 of those. Here, the mother was a non-smoker and the baby was normal birth weight, 186. And last, here, the mother was a smoker and the baby was normal birth weight, and there's 132 of those. So we're going to make a list summarizing the 4 key facts shown in the table. We're going to draw a Venn diagram to represent the table data. And then based on the Venn diagram, we're going to try and summarize the results of the study. So first, if we want to look at a list summarizing the 4 key facts shown, all it does is go through those 4 numbers that I just went through. 18 babies were born with low birth weight to smoking mothers, 132 babies were born with normal birth weight to smoking mothers, and so on. So what you want to do now, you could have made this Venn diagram a number of ways. They chose to look at the set of smoking mothers and low birth rate. But you could have also chosen to look at normal birth weight and non-smoking mothers and still created a Venn diagram that gave you all the same information. So you're going to look at one value of each variable. And so they chose smoking mothers and low birth weight. So here, the 132 that are outside the overlap, this would be babies that were born to smoking mothers, but they had normal birth weight. In the overlap, these 18 were the babies born low birth weight, but also to smoking mothers. And then these 14 were low birth weight, born to non-smoking mothers. And then the rest of these out here are the 186. They're outside both sets, so they are non-smoking mothers born with a normal birth weight. And like I said, you could have set this up differently. You could have looked at values of non-smoking mothers and normal birth weight. You would have just rearranged where those numbers fell within the Venn diagram. But there are multiple ways to communicate the same information. The last part of it asked us to kind of analyze the study, and it says, notice that normal birth weight babies were much more common than low birth weight babies. among both smokers and non-smokers. However, the smoking mothers had a lower proportion of normal birth weight babies and a higher proportion of low birth weight babies. So this suggests that there is some precedent for a correlation between smoking mothers and low birth weight, although we would have to do further experimentation and have further studies to indicate a causal link. All right, so human blood is often classified according to whether 3 antigens, A, B, and Rh, are present or absent. Blood type is stated first in terms of the antigens A and B. Blood containing only A is type A. Blood containing only B is type B. Blood containing both A and B is type AB. And blood containing neither A or B is type O. The presence or absence of Rh is indicated by the word positive or negative, or its symbol. Table 1.2 shows the 8 blood types that result and the percentage of people in the U.S. who have, with each type in the U.S. population, Draw a Venn diagram to illustrate these. So this is just to illustrate that we can have a Venn diagram with 3 overlapping sets that creates 1, 2, 3, 4, 5, 6, 7, and 8 sections to fill in. So in this case, we have blood type A positive, B positive, AB positive, O positive, A negative, B negative, AB negative, and O negative. And you can analyze that Venn diagram for how those relationships interact. So you have the set of A, the set of B, the set of Rh positive. So those outside, those that don't have antigens A or B, but are Rh positive, are type O positive. Those out here, outside A and B, but are not Rh positive, are considered O negative. So you can go through this Venn diagram and make sure you understand how every section occurs. For example, these people have blood types A, antigens A and B, and they're also Rh positive, so they're AB positive. Whereas these people have A and B, but are not Rh positive, so they're AB negative. So I think there's one example in the problem set where you will be trying to create from a table like this a 3-set Venn diagram. All right, I'd like you to pause it here and try and analyze this one. So the student example is a study about tomatoes and cancer, and you're given a data table that shows convincingly that high consumers of tomatoes and tomato products are substantially decreased risk of numerous cancers, although probably not all cancers. And what they want you to do is consider the table and draw a Venn diagram to represent the data. Make sure to include a universe and label every part of it. We'll go over this in our next class. This is going to be your problem set, and I'll post that on the PDF.